Okay, so welcome to our instructor training class meeting, first meeting for our connecting course in spring 2018. Again, everyone in this course should pretty much be folks who have been in the course before, so I'm not going to spend time going through the basics of the course format. If you have questions about that, you can go back and watch any of the first meetings for the introduction course, routing, switching essentials, or the scaling course. What we're going to do today, we're going to jump right into the connecting networks information. I want to quickly show you that this is only 8 chapters. So this particular course is much shorter than the course that you've had in the past. It also gives you enough time, hopefully, that at the end, when you complete your final exam and make higher than the 75, which you should, that you will get your voucher and you will go take your CCNA exam. So it gives you some time that we should be able to kind of jump ahead and let you do some work to get ready for your CCNA. If you don't have your CCNA, I highly recommend it because it is not technically required for instructors anymore to have their CCNA, but I always like to practice what I preach. So I strongly recommend you get your CCNA so that when your students say, well, you didn't do it, I can say, yeah, I did. And so that is one thing I definitely recommend. We're going to start. Now, this entire section on connecting networks deals with, let me jump back real quick, deals with what I call the WAN or connecting WAN. So we're going to look at WAN concepts today. Chapter 2 is point-to-point connections. We're going to look mainly at point-to-point protocol. With branch connections, we'll be looking at VPNs, GRE tunnels, those types of things. Access control list is a very, very important chapter. This used to be in Chapter 2, actually, the routing, switching essentials class. Now it's out here in connecting. And I can tell you that access control lists are one of those things that get used in the Cisco IOS in so many different ways. They are obviously used for security purposes. They're used for traffic shaping. They're used for control to VTY lines. They're used for applying policies. You name it, and it is out there. Then we're going to go into a couple chapters that get into security monitoring, network security and monitoring, quality service QoS, which is very important on our converged networks, network evolution, and kind of where we're going with networks in the future. So some of that deals with our SDN, the software-defined networking, programmability in networking, and then our network troubleshooting chapter. So again, it's going to be a fairly quick course in that it doesn't have the level or number of chapters that you normally see in a course. We're going to start out talking about WAN and what a WAN is. When we talk about a WAN, we know it means a wide area network. So when you define a WAN, you're defining it as a network with no geographical limitations. So I like to tell my students it's really just a WAN is a bunch of LANs connected together by some type of technology. What we're going to do in this particular course is we're going to look at this block right here in the WAN. We're going to look at the WAN switches. So we're going to look at the layer 1 and layer 2 technologies used to build a WAN. Are they necessary? Yeah, because when the internet goes down, everybody freaks out. In fact, I was reading today, I don't know if any of you have seen this, but in the next Falcon Heavy, or not Falcon Heavy, but Falcon 9 launch on Saturday, SpaceX is going to put 2 microsatellites up that are going to test their satellite-based broadband they're wanting to offer. This satellite-based broadband is going to offer gigabit speeds with 25 to 60 millisecond delay times. So it's really and it could be a game changer if they make it work, especially in rural areas or in places like one of the places they talk about is Alaska, where it's extremely difficult to get internet into those areas. When we look at WAN, now one of the things that I always get tickled when we talk about high-speed internet, even the high-speed internet out there, and I've got 11 megabits per second on my DSL. I know people around who have, Spectrum, and through cable they get 200 megabits per second, 300 megabits per second. What is really the slowest NIC you can buy right now?
Probably a gig.
Yeah, gigabit. So,
yeah,
gigabit NICs, 1,000 megabits per second. So when we start talking about high-speed internet, and high-speed WAN connections, most of them really are not that high speed. They're high speed compared to what we had when I was growing up, which was a Dialup 2400 modem, or then a 56, then 96, then a 56, then or 14.4. Kids today, I feel so old when I start talking about. Yeah, back in my day, I started with a 2400 ball modem, but it really is a totally different ballgame. We also have new WAN topologies, not topologies, but new WAN technologies coming up. We'll talk a little bit about, like 5G, which is amazing. But some topologies we see in WANs, point to point. Obviously, that's from one point to another point. This type of technology, a point-to-point technology, doesn't have to have a lot of addressing, because pretty much when you leave site A, you go to site B. Hub and spoke. This is where, and this could be multiple different ways. This could be using switch virtual circuits or virtual circuits where there's a VC or a virtual circuit from the hub to spoke A, and then a different one to B, and then a different one to C. Or it can actually be a virtual circuit to where there's a circuit that all three of these connect to. So that's hub and spoke. There's the full mesh topology, where all of these connect to the exact same virtual circuit, so they can all talk to each other. And this is a very important one. This is dual home, and this is how we do redundancy with multiple ISPs, or if we need multiple connections back to the central office. One of the things I always tell people when looking at WAN topologies, especially when looking at going with dual home connections to other ISPs, make sure you know what's on the other side of the ISP. So, for instance, if you go into a local telecom provider, and then you go into a local cable modem provider, make sure that both of their connections aren't up to AT&T or Sprint up here, because if they are, you're wasting your money having them as dual home connections, because if AT&T or Sprint goes down, then you've got a single area of failure. A lot of people forget to ask what's upstream. Networks are constantly evolving. Again, the small office. I know so many people now who work from home or who go to the office, once or twice. There's been a bunch of jokes about that huge Apple facility that Apple built out in California, about how it's such a waste because no one goes to the office anymore. Everyone telecommutes. And I think you will see this and continue to see this more and more. We're sitting here right now and we're having class over just the internet. So it's a neat thing to be able to do. But all of that requires that we have good broadband access, which is something that in the U.S. we don't have, unfortunately. Here's connecting a campus network. So we're looking at our different VLANs, marketing, sales, finance, accounting, engineering, production, all these VLANs connected into a routers, which then connect to a firewall and go out to the internet. So this is a business campus. And this is all talking about a fictitious company called Span that is growing. How it went from a small office, home office, expanded to a campus network, and eventually started having branch offices throughout multiple cities. And then throughout the world. And so now you've got a global network where you've got central offices connecting branch offices in multiple cities, a telecommuter or sales person going around who's using a VPN to get back into the central office, and then also workers working from home. One of the things, I do want to mention something here. One of the things people don't think about with telecommuting is how telecommuting gives you access to not just workers who want to work for you. Hold on one second, folks. I'm shutting the door. Somebody's vacuuming. Welcome to the world of live classes. But not just the fact that telecommuters like to work for your company because they don't have to come into the office, but the fact that you can get the best talent. The people you hire do not have to live in the city where the corporation is. It's the absolute best accountant in the world, or the best accountant around for your particular program, lives 4 states away. With telecommuting, that particular person can go to work for you, and that's huge. This is very important when we think about WAN technologies. The WAN technologies we discuss in this class all occur at layer 1 and layer 2. So they're either a physical layer component, which is some type of DMVPN or dense wave multiplexing. They're electrical signals, how things move across a physical component, or they're layer 2 services or layer 2 protocols, such as HDLC, which is high-level data link control, which is the default encapsulation method on our default layer 2 protocol on Cisco serial links. PPP, point-to-point protocol, which is a layer 2 protocol. Frame relay, Ethernet, also layer 2. Ethernet WANs, MPLS, VSAT, and broadband. All of these are layer 2 services. So DSL and cable modems are layer 2 services. Some common topology or common terminology here. CPE, customer premise equipment. That's the equipment owned by the business. All right. You've got the data communications equipment, or DCE. That's also data circuit terminating equipment, DCE. This provides clocking. So remember, anything that's DCE is data circuit terminating, and means it has clocking. Data terminal equipment is the customer equipment that passes data, connects to the DCE. Typically what we used to have, and in some cases still do have, are CSU DSUs that connect to a router, or a CSU DSU or TSU that's inside of a router. You have a demarcation zone, which is the demarcation between the customer equipment and the provider equipment. In Europe, it's different. The demarc is actually the DCE. In the US, many times it's right outside the DCE. This local loop is it's either fiber or copper that connects you to the CO switch. This is what causes all the problems with DSL, because there's I think it's 15,000 feet, 1.5K limit on how far you can go from a DSLAM or the switch to a DSL modem and get really high-speed internet. And then the central office, obviously, is that central office that houses the switch, or it could just be a switch on the road. And then the toll network, which is where you go out to the LAN service provider. Are there any questions about these different pieces of terminology or different devices?
Not at this time.
Okay.
No, I'm good.
All right. So some common WAN devices. Hopefully you don't have dial-up modems. You both are probably old enough like me. You actually did have dial-up modems.
Yep.
Access servers. Access servers which would connect to dial-up modems. So you'd have modem banks that would dial into the network. This day and age, we have broadband modems, DSL or cable modems. And then the CSU, DSU, again, we don't have as much anymore, but we used to have, especially if you have, well, if you have a leased line, you may have a CSU, DSU. And the WAN switches are the switches inside the core here, which is where the service providers do their magic with things like frame relay, switch virtual circuits, PVCs, permanent virtual circuits, and MPLS, and all those different things that are inside of there. Now, this is the best way I can explain circuit switch networking is, remember the old movies where you used to call the operator and the operator would say, who do you need to speak to? I need to speak to Bob Smith. Well, the operator would literally connect your phone cable to Bob Smith's. And then when you were done talking, would disconnect it. So it's circuit switch networks. It is a dial-up technology. So you dial and there is a circuit that gets created. Okay. That circuit is maintained during the time that the conversation is taking place. And then once that conversation is over, that circuit is torn down. Okay. So there's a continuous circuit from beginning to end. Now, for most of our technologies today, this is not used anymore, but it was used in the old days with PSTN, Public Switch Telephone Networks, or it was used with ISDN, which we'll talk just a little bit about in this chapter, but is not really big anymore. This is our more common system now, and this is where a packet switch network, where we take things, we segment it, we throw it out into the cloud, and then it finds its way through using different switching / routing methods, more switching than routing. But this type of method here is better because you don't have to, first off, you don't have to maintain a dedicated circuit. You can have it. You can have a virtual circuit. But you also don't have to always use the same path. The circuits can be built and rebuilt depending upon what is available and what's the fastest path. So here's our different options that we can actually get out there and get on the WAN or use WAN connections. If you have a private connection, you could have a dedicated leased line. That's like a T1 or an E1 or T3 or E3 or faster. And these are leased lines that are leased to you between your different sites. If you have a switch connection, you could have a circuit switch connection, which would be PSTN or ISDN. That's the lowest level. And then you have, or packet switch, which could be Ethernet, Metro Ethernet over fiber, which is one of the fastest ways to do it. MPLS, you could build an MPLS file. Now, obviously, there are some public MPLS files too, so don't think that it's just private MPLS. Frame relay and ATM, that's some technologies that have really fallen by the wayside here recently. On the public side, if you connect to the internet, you're going to do DSL, cable, or wireless, and especially now as we're moving into wireless technologies like 5G that are going to be super, super fast. Here's a layer 1 technology that allows you DWDM, dense wave division multiplexing, which lets you actually take a single fiber, and on that fiber you can do dense wavelength division multiplexing. Will allow you to run up to 80 different channels on a single piece of fiber, and each one of those channels can hold a gigabit worth of multiplex signal. So this is what is used when you're connecting to SONET, SDH. In other words, this is what's used to go across the large fibers that are laid under the sea and that connect continents. Okay, we use DWDM over SONET or SDH. So, simple lease line. Now, I will tell you, it's been a long time since I've even heard of anybody using a lease line. I know you can still do it. A lot of people lease it and go into an MPLS cloud. But a lease line is a lease, either T1 or E1, and a T1 is 1.544 megabits per second. E1 is 2.04. A T3 is 43.7 megabits per second, and an E1 is 34.368 megabits per second. Why would you do a leased line? One of the biggest reasons is simplicity, because it appears as a point-to-point link from one office to another office. The other is quality, and not just quality in terms of your guaranteed quality, but another thing I mentioned is service level agreements. When you have a leased line, you have a service level agreement where if it goes down, you can call and really bark at somebody and you can get it fixed fairly quickly. A great example between this and something like a business DSL. You know, my wife has business DSL to her nonprofit. We used to have a leased line. Now, it was $300 a month for that, but if it went down, they had it back up within the hour. With business DSL, they may say, well, we'll get somebody there tomorrow afternoon between 12 and 5. Different service level agreements.
Yeah, my son works for Windstream. That's all he deals with is TV.
Do they work for Windstream? Okay, works for Windstream. And that's the thing. That's a whole different service level agreement for business DSL, and even home DSL is even worse. So many places do want leased lines so they can call somebody and say, I want this fixed now. It is also pretty much always available, and it's dedicated to you, so the quality is there. Now, the problem is cost. It is very expensive. The other issue is limited flexibility. In other words, if you buy a T1 at 1.544 megabits per second and need a little more speed, it can burst over that, depending on how it's been configured, but not easily. Plus, it's very difficult to get some of these leased lines from one site to another because they just don't exist. You don't have the physical cabling in place to do it. And getting it placed is super expensive. Now, I'm not going to spend much time on dial-up because dial-up is, it's been so long since I've even used a dial-up modem. Used to be a couple years ago, I heard a hacker say if somebody put a gun in my head and said breaking a network, he would immediately start doing war dialing. I don't think you'd do that anymore because they're really, so many dial-up modems are not even, they're just not there. Parts of the world, I'm sure, still use dial-up, but it's just not something that we have a great deal of. Same thing with ISDN. ISDN used to be a huge part of the CCNA curriculum. We had to learn everything about it, how call setup took place. By the way, ISDN is circuit switch, so it actually creates a call, manages the call, and terminates the call. And so we spend a lot of time inside of there. Now what you basically need to know is that BRI, or basic rate, is 2 64K channels and 1 16K D channel, so 2 Baird or 1 Delta for signaling channel. And then primary rate ISDN is 23 Bs if it's a T1, and 2 D channels, 3 D channels, excuse me. Okay. Actually, it's 1. They got should be 23 Bs and 1 D for 24 total channels, which is 1.544 megabits per second in North America, and it's 2.048 in Europe. So they do a different signaling standard. But this is the big thing. It has call setup. It's less than a second. Each one of those channels is 64K. If you ever heard of a fractional T1, so you bought 128K frac T1, you'd have 2 B channels. It can be used for phone, still used for phone lines, and is used for phone lines. We also used to have an entire multiple chapters on frame relay, which we don't anymore. But it was a layer 2 standard, and is a layer 2 standard used to create terminal virtual circuits using DELCs. And DELCs are locally significant. Again, we don't even go over how to configure frame relay in the CCNA, and it's not really tested on the CCNA. This one, ATM, just remember it's 53 byte cells, 48 bytes for data, 5 bytes for control, and that's really it. This was going to be the be-all, end-all. It was going to do everything because it did voice, video, data, all of it over one thing by multiplexing. The problem is ATM switches were so hard to configure, and ATM was such a complicated technology that Ethernet got faster and faster, and basically Ethernet took over. And that's where we're at now, that most people, if possible, for instance, like us, we just buy dark fiber and run our Ethernet across it. Now, MPLS, this is a pretty neat technology. We don't spend much time in here. It is basically what you're going to do on your end is you're connecting with one of the known technologies, so Leased Line, Metro Ethernet, and then you go into the provider's MPLS cloud. And the best way to think of MPLS is it's a tagging system. So basically the traffic that comes in gets tagged, and then that tag is used to label switch the information through the MPLS cloud to the destination. What it allows the service provider to do is take one MPLS cloud and move multiple different businesses or companies' information through that MPLS cloud securely by making sure it's separated by tags. VSAT, used a lot by the military, but satellite, and this is also coming into where we'll see more and more, especially if this new SpaceX system works. We may have some actual decent options for satellite internet. Now, DSL. It is a broadband technology that can be used both by companies and by individuals. It has a DSLAM at the point of presence, and then that DSLAM goes to the DSL modem, and you can get fairly fast speeds out of DSL. Most of it is asynchronous DSL, which means your download speed is much faster than your upload speed. There is synchronous DSL, but it's not very common. The problem with DSL, especially in many places, is it does run over copper, the existing copper line. And the distance from the DSLAM to the DSL modem has to be a certain distance for you to be able to get really high-speed internet. For instance, where I'm at, they had to put in a special amplifier, basically, so I could get faster speeds. I was at a point of only getting 2.5 megabits per second, and I was ready to shoot myself in the foot to get faster internet. So that is one of the problems with it, and that is a problem also with a cable modem. So there are large portions of the United States where you can't get decent internet connectivity because you're not close enough to a DSLAM for DSL, or you're not close enough to a CMTS for a cable modem provider. So cable literally ends a quarter of a mile from my house, both ways. And so if they would just bring it, and there are 5 houses between there, they would just bring it, they would get a large number of people to sign up for their internet, especially if they could give me 100 or 200 megabits per second, I'd do it in a heartbeat. So until companies start pulling fiber to houses, which will be a long time because they don't see any economic benefit to do so. So unless they're forced to do it for some reason, then we're stuck with pretty slow internet if you are a rural customer. This, however, may be the saving grace, and that is wireless, especially not municipal Wi-Fi or WiMAX or even satellite. But what's going to be the saving grace is going to be the cell towers. Right now at my house with my phone with 4G, I can get about 23 to 25 megabits per second download. If we get 5G, there's then going to be the possibility of just saying, hey, forget this, I'm just going to grab everything using my wireless carrier. And as long as we don't get into a situation where they're throttling bandwidth, which obviously we're back in a problem with that, then we will be able to get very fast connections with 5G, and that may actually solve some of our rural access problems. These technologies we'll talk a lot more about when we talk about extending the network, but different types of VPNs. We've got different tunnels. One is a SitetoSite VPN. These are tunnels that begin and end on company-controlled devices, so that really in a SitetoSite VPN, the hosts on the other side of the VPN tunnel don't even know they're going through a tunnel. And that's only possible because you're able to control both sides, and you know what you can configure each side. These are great because they save money. No longer do you need the dial-up modem banks that you had before. The tunnel can be secured with IPsec and security protocols. It's scalable because as you add more sites, you can just create more VPN tunnels. And it's compatible. It will run across our existing broadband systems. The other type of VPN is a remote access VPN. This type of VPN requires you loading software on the device, and this will be used by like a teleworker that's staying at a different hotel every night. So the teleworker you don't control the router that particular hotel owns. So the teleworker has to create a tunnel from their laptop or device all the way back to the corporate network. Now there's other ways of doing this besides loading software. You know, Palo Alto has software you can load to do their VPN tunnels. Cisco has Cisco AnyConnect, but you also can do just SSL VPN tunnels, which use a web browser to connect and create a tunnel. But the main difference between a site-to-site VPN and a remote access VPN is where the tunnels end. Site-to-site, again, is from company-controlled device to device. In remote access VPN, it is from the actual host to a company-controlled device. And when this happens, you actually get multiple IP addresses on the teleworker PC, and then the traffic can be, there's a way to do several things. One is called split tunneling, where you can have only the traffic going to the corporate network goes to the tunnel. If the teleworker goes just to the normal internet, it would not go through the tunnel. Or you can have all traffic go through the tunnel and appear to originate from the company head office. Are there any questions about those? About those two VPN technologies? Okay. Well, I'm not going to spend a lot of time on this selecting a WAN service. When you teach this class inside of your actual classes, I do suggest you have your students do the activity in the lab where they go in, and I'm going to have you do it too, but where they research their local options for high-speed internet. They research the options for what they can get and what's available, because it gives them a chance to start looking at some of the things we have to do every day in our job as networkers, and that is go in and evaluate different services and determine what services are needed and what those services can do for our businesses. And folks, that's it for chapter 1. Are there any questions?
No,
Told you
pretty good.
you wouldn't have
That's
any
pretty
problem
quick.
today.
Yeah.
Yeah, there's
Very
not
short
much-
chapter today.